Hey guys, and welcome to task 4.2. This is just the first of two videos that are going to help you solve equations with rational functions. Now, that is our goal, to be able to solve equations with rational functions. And just a reminder, what is a rational function? You may like to think of them as fraction functions. What do I mean by that? Fraction functions. They're just anything with variables in the numerator and denominator. So here is an example of one. We're actually going to work up to this one. This is one of the last examples in the task today. But you'll see that we have variables in fractions. We have variables in the denominator. We have entire factors in the denominator. So this is part one of the video, which is going to go over one method. The first method I like to call clear the denominator. So when we're trying to solve an equation like this, I don't want to deal with the denominators. I don't want anything to do with the denominator. It makes it so much more difficult to have x in the denominator. So let's use this method that gets rid of the denominators across the entire function, across the entire equation on both sides. So you'll see method number one I like to call clear the denominator. And I'm going to multiply both sides of the equation by the least common denominator. Essentially, I'm going to multiply both sides of the equation by everything I see in the denominator, everything. So in this case, when I'm looking at my very first example, all I see in the denominator is x minus 1. So if I multiply everything on both sides of my equation by x minus 1, I will clear the denominator. Let's see what that looks like. So x minus 1 times 1 is just x minus 1. X minus 1 times 1 over x minus 1, well, this is what it looks like. It looks like x minus 1 all divided by x minus 1. Again, that's the factor x minus 1 divided by the factor x minus 1. And 0 times x minus 1 is still 0. So here we see why clearing the denominator is such an effective method. This right here, x minus 1 divided by x minus 1, is just itself. It's just equal to 1. Anything divided by itself is just 1. So now I have x minus 1 minus this whole thing right here just equal to 1, equals 0. Well, x minus 1 is x minus 2. Add that 2 to the other side, and x equals 2 is our solution. So clearing the denominator simplifies the equation to just be a linear, sometimes quadratic equation we know how to solve. There's no denominator left, so we can use those solving methods we've been working on since Math 1. Let me set you up for the second example. Again, clearing the denominator means multiplying both sides by a denominator that is least common denominator. So in this case, I have to look at both the x plus 1 and the x plus 4, but it's the same idea. I want to multiply both sides by that entire denominator, both the x plus 1 and the x plus 4. Again, both the x plus 1 and the x plus 4. So let's see what that looks like. Well, I need to distribute this whole thing to the first term, x times x plus 1 times x plus 4, all over x plus 1. Plus, let's distribute it to the second term as well, 2 times x plus 1, x plus 4, all over x plus 4, equals x plus 1 times x plus 4. So I'm just multiplying that to 1. Okay, well, I see x plus 1 over x plus 1. That becomes just 1, or that those kind of cancel each other out. They divide out to equal 1. So all I'm left with is x plus 4, plus, same thing. X plus 4 cancels out or divides with x plus 4. So leaving with just 2, x plus 1 equals x plus 1 times x plus 4. Now that we've completely eliminated our denominator, again, if we go back up, the whole point of this is to clear the denominator. Since we've completely cleared the denominator, we are just going to multiply this out and solve it just like the linears or the quadratics we're accustomed to. So x times x is x squared. X times 4 is 4x. 2 times x is 2x. 2 times 1 is 2. X squared plus 5x plus 4. Multiply that out using a box, multiply it out using FOIL, using distribution, any way you'd like. So let's now move everything to the same side. Subtract x squared from both sides. Subtract 5x from both sides. And subtract 4 from both sides. So x squared minus x squared, those are gone. I actually had 4x plus 2x, so that's 6x minus the 5x, leaving me with just an x. And then 2 minus 4, leaving me with negative 2. And this side perfectly canceled out. Leaving us with it, x equals 2. So I said I was just going to set you up, but I actually solved it all for you. There is a third example there. Try that third example and then come back to see a video for my second go-to method.